Welcome back to P3. Today we're looking at Unit 2.5. We're looking at sketching modulus graphs where the modulus is outside of f of x or the modulus is just on the x within that f of x. So let's have a quick look at what's happening. So if I have an x squared graph, not the best one, and this is my y equals f of x. Now, if I want to look at what happens with, say, f of x is inside the modulus, that means that I can't have any negative values of y, because everything on the right hand side here is inside a modulus sign. So there can't be any negative values of y. So when I'm looking at my sketch, instead of the sketch now going as it did on the previous one all the way down, what I get is this part and this part will stay the same, but then this top bit will be that mirror image. So what's happening is this section here underneath the graph is going above the line. Okay, so it becomes a mirror image. If I look at what happens with, very quickly, y equals f of, and just the x can only be positive, then what that means is that what I see on the positive side of my graph, so if I look at this one, my positive side goes down and up like that, I get the same thing on the left hand side. So this one then becomes a mirror image in this line y equals, okay, y axis, or x equals 0 line. So if I start again from the start, you've got a graph. If the modulus is outside the f of x, you can have no negative values of y, so they become positive. If it's inside, then you can have no negative x values. All the x values that are negative give you the same answers if they are positive, which is why this part that's on the right side, the positive x's, is repeated on the left side, the negative x's. Let's have a look with some actual equations, actual functions. Okay, let's have a look at this one, x squared plus 8x minus 3. So I think for this one I would probably just complete the square here. Minus 16 minus 3, so we're looking at x plus 4 squared minus 19. Okay, so I can now see that that sketch is, I know it's going to hit the minus 3 on my axes here, but I know it's going to go across to minus 4 and minus 19. So that is, just going to do it somewhere down there as the minimum value. Okay, so something like that. I'm just going to very quickly just a quick re-sketch, just so that I can fit it on. It doesn't have to be perfect, that's as long as it's the right shape and your values are right. So minus 4 minus 19, that's that minimum point there. Easy, nicely done. Once I got that one, from here it should be quite straightforward. So part B, only the x is in the modulus sign, so that means that this part of the graph is basically repeated twice. So it's going to be, so not twice, but it's repeated onto the other side. So it's going to be something like that. And then part C, we can have no negative values of y, because the whole that f of x is in the modulus sign. So we go down, we get that bounce up and down, and then finally up. Okay, and again it's about marking on the value. So this is -4, positive 19 now, and it's crossing here at positive 3. Okay, need to get those values accurate. You could also solve the quadratic for these points where it crosses the x-axis. So if you imagine this one was equal 0, I'll rub it out, but just imagine that. You take the 19 to the other side where the 0 is, positive 19, take the square root, and then it'll be -4. So -4 plus or minus root 19. So you've got, this one would be -4 minus root 19, and this one would be -4 plus root 19. Okay, and that's those points there. If this was on the part B, you would have -4 plus, sorry I missed the plus sign, plus root 19, and this one would be root 19 minus 4. So just being careful there. And of course part C is the same as part A. Okay, gone through that quickly, hopefully that one's okay. I'll look at one more question, and this is the one I wanted to look at. Often in the exam they'll give you a question where they won't give you what the function is. They'll just tell you that this is y equals f of x, for example, or g of x, or h of x, and they'll give you sets of coordinates on it. Okay, and then they'll ask you, they'll ask you to apply transformations, and then what happens to each of these coordinates. And equally, they could ask you to sketch them as well. It really depends on the question, but they do like to sometimes give you questions where you don't know the actual function. So if I was looking at this one, again, if I was looking to do y equals and then an f of x inside my modulus sign, I know that this part of the graph and this part of the graph would become positive. So when I'm doing that kind of sketch, I know that this is coming down here. Then I've got my sketch again, just trying to keep the same kind of shape. It doesn't have to be perfect for a sketch, but it's all about the shape and the points. Okay, and then it would just be a matter of plugging in any and all values. So you can see here they're pretty much all going to stay the same, except for this one's going to become 5 and positive 4. And again, if I was going to do y equals f of, let's do it better, and just the x was modulus, then I've got to think, right, everything on the right side, which is like this, is going to appear on my left side. So it's going to come down and back up. And then your values, they're nice and easy. 3, -3. That one's at 7, that one's at -7. This is at 5 minus 4. This is at -5, -4. This now is crossing at 10. Okay, and it's nice and straightforward. Okay, so just remembering what happens. Think about it logically, when the modulus is outside, everything on the right of this equal sign is positive. So y cannot be negative, nothing below the x-axis. This side, what's happening is that because the x can only be positive, what happens to the y when you put a negative x in is the same as what happens to y when you put a positive x in, which is why this side of the graph is repeated this side of the graph. Now I'll give you a few to do, and I'll go through them at the end. Okay, so first let's complete the square. That's 5 over squared minus 25 over 4 minus 7. 7 fours are 28, so 28 over 4, so we've got 53 over 4 there. So my initial sketch of g of x is going to cross the axes at minus 7, the y-axis. So let's have a look. 5 over 2, and then minus 53 over 4 is 13 and a bit. Cross that minus 7, so something like that. Well, this is the coordinates 5 over 2 minus 53 over 4. Let's cross in there at 7. And these values would be 5 plus root 53 over 2 and 5 minus root 53 over 2. Or you could put them in as decimals, you know. But either way. Now, the second one now, part B, I'll do that one in black. Exactly the same, but the part that is below the line now needs to go above the line. Put that part of the graph there. Something like that. And then of course these values are the same. 5 over 2 but a positive 53 over 4 for the y. Positive 7 where it's the negative 7 there. Okay, so just putting in your values, and then the final one when x is positive. Let's just try and give myself a little bit more room here. So it's just this positive part of the graph here, and then on the same on the negative side. So it's going to look something like a W sign, the letter W. Okay, crossing here at minus 7, and then I'll put these in decimals this time. That's 6.1 minus 6.1. Just as a little bit of a change there. Okay. The next two I'll just pop the answers up for. Actually, I'll just talk you through the first bit, and then I'll pop the answers up for the rest of it. So when you're looking at this, when g of x is 0, we know that x is going to cross the x-axis at 1, 3, and then negative 2. Obviously coming from my 3 roots here. It's, if I look at the x's, it's a positive x cubed. Okay, which means you know it's going to be going up this way. So you think back, yeah? Comes from the bottom and up. Okay, now just before I do that, just double check. Let's multiply these. Minus 1 times minus 3 is plus 3. Times by 2 is plus 6. So I should hit this x-axis at plus 6. So here we go, up, down, and back up again. And here we're hitting the axes at 6. Okay, I'll just pop the other two answers up now. Okay, now with this one, we need to make sure we draw both parts of this. So we're looking at the first part. This is linear, so nice and easy. If I substitute my, my -5 in here. Let's just draw my axes. So -5 in, times by -2 is 10, take away 6 is 4, so -5, 4. So this is my first point, -5, 4. And I'm going down, you can see in 2's I got a gradient, sorry, of -2. But let's look at my last point there, -1 goes in. -2 times -1 is 2. 2 take away 6 is -4. So we're looking at -1, -4. Okay, now just move that up a little bit, give myself a little bit more room. I'll rub this out. Let's get my ruler out. Now it's a straight line. I will just roughly join out. I know it's a sketch, but I'm just going to use a ruler here just to help me out. And that's my first bit. So even though it isn't actually equal to that -1, I can draw it up to that point because everything up to that exact point. Looking now at this second part here, where I substitute the -1 in, so -1 goes in here, -1 plus 1 is 0. So when x is -1, this is going to be 0. So at the same point, just up here, we're looking at there, and then it's going to be an x squared graph. I'm going as far as 2. If I substitute 2 in, or I'll substitute a few points in, so let's substitute 0 in, we get 1. And then if I substitute 2 in, 3 squared, 9. So here we have just that curve here, and at this point here will be up at 9, if you will, like that down at 2, but I'll take those out for now. So that's going to be at 2 there, 0. This is at -1 at the bottom. What was it? -1, -4, wasn't it? And this is how this function looks. Now, stating my range, well, my range is quite clearly between -4 and 9, and there's no gaps in it because this gap here is obviously this bit, so there's no gaps in it. So my range here, which is my f of x, is between 9 and -4. Okay, now I'm taking the equals off there because if you remember at this point, when I substitute the -1 and it doesn't actually equal this -1, but it is the lowest point. So I do have to be careful that I've not put that equals in there. Now after that, part B, part C, they should be quite straightforward. Okay, so if you remember, like part B now, with my modulus of f of x, I just need to change everything that is below the line to being above the line. So that part of the graph there will not change. The part that will change though is that straight line. So we've got a straight line coming down, but then it's going to go up, and it needs to kind of finish in line with that start of that one. So that's at -1. Obviously this is at -4, 5. Up here is at 9. Here now is stopping at -1, 4. Crossing this line here, we said it was at 1. Didn't actually put it on the original there, I should have. The only other point really I could do working out is this point. Okay, so substitute when y would equal, my f of x would equal 0. So if I take 6 to the other side, divided by 9 is 2, so we're looking at negative 3 at this point, and I can put it on the original as well. And then part C, let's do that in green. This is just the right hand side of the graph repeated. Let's try and get it the same as the others. At least similar. And obviously you're not going to get marked down for it not being perfect. And there we have it. So if you have found this video useful, please like and subscribe, and feel free to give us some messages in the comments if there's anything in particular you want me to go through. Till next time.